All right, this lesson is on applications of trig functions. You will be using trig functions to model and solve real-life problems. Start with this one here. A surveyor is standing 50 feet from the base of a large tree. The surveyor measures the angle of elevation to the top of the tree is 71.5 degrees. How tall is the tree? All right. So we have some information here, and we're measuring the angle of elevation. Angle of elevation is measured from the horizontal, meaning that here's the angle of elevation, okay, going up. That's why it's elevation. And then the other one would be the angle of depression. Okay, so this is the angle of elevation. And this is called the angle of depression. Okay, so we have an angle of elevation to the top of the tree is 75 or 71.5 degrees. So here we have a triangle, a right triangle, and we know the angle of elevation is this angle going up, looking towards the top of the tree. And the surveyor is 50 feet away from the base of the tree. So this is our problem here. And what we're trying to find is how tall is the tree. So that would be the height of the tree. I'm going to call H is what we're trying to find. Now, only given this information, then you're going to have to use a trig function. We know that this is opposite side to the opposite leg to the angle, and this is adjacent leg. Which trig function would we use if we have the opposite and the adjacent and the angle? Well, you should know that we're going to use tangent. Tangent of the angle is equal to opposite over adjacent, and the opposite is the unknown, and the adjacent is 50, and my angle is 71.5. How you finish this off is you multiply both sides by 50. So get rid of that. So now you have H is equal to 50 times tangent of 71.5 degrees. Make sure you know how to put this in your calculator. Make sure your calculator's in degrees. And you're going to get approximately 149.43 feet. Okay, let's try another one. You are 200 yards from a river. Rather than walking directly to the river, you walk 400 yards along a straight path to the river's edge. Find the acute angle theta between the path, between this path and the river's edge. So here you are, and here's the river, and you are 200 feet away. Instead of walking directly, you walk at an angle towards the river, and that path is 400 yards long. Okay, so here is the triangle that we want to work with. You're 200 yards from the river's edge, and you're going to walk a path that's 400 yards. What we're trying to find is find the acute angle between the path, between this path and the river's edge. So that angle would be in here. Here's your path, here's the river's edge. Now you have to decide which trig function represents this picture here. We have this angle here, and this would be the opposite leg, and that looks like the hypotenuse, opposite over hypotenuse. So we know that that's sine of theta is equal to opposite over hypotenuse. So sine of theta is equal to 200 over 400. This is my ratio. And I can reduce this to a half. And now you have to know that on your unit circle, a half, where sine is a half, okay, would be a certain angle. But if you didn't, let's say this came out to a fraction that is unknown, you could actually use your calculator. And you use your calculator by taking the arc sine of both sides. Okay, the arc sine and the arc sine. The arc sine on your calculator looks like this. Okay, so these two cancel out and you get theta. And then by putting this in your calculator, you should get $30. Or you might have already known that on the unit circle, 30 degrees is 1/2. Sine of 30 degrees is 1/2. Okay, next. Find the length of the skateboard ramp. See if you can work this one all the way through by yourself, and then we'll check your work. Alright, if we want the length of the ramp, that would be the hypotenuse. And we have the opposite, so that would be sine. So that would be sine of the angle is equal to opposite over the hypotenuse is what we're trying to find. We're trying to find the hypotenuse of my triangle. Now I'm going to do a thing here where I swap these two out, or you can think of it as multiplying by h on both sides and dividing by sine of 18.4 degrees, or you can just switch this out. So that means h is equal to 4 over sine of 18.4 degrees. And that works because you have this proportion going on. And this would be h over 1 is equal to 4 over sine of 18.4. Okay, this all can be put on in your calculator. And you should get .67 feet. Now, I forgot to mention that when you're doing all these, you should actually take a look at your answer, see if it makes sense. If this is the ramp and this is 4 feet, your answer is 12 or close to 13 feet. That makes sense. Okay, so if you got an answer like 4, you know you did something wrong. Or if you got an answer like 360, then you know you did something wrong. So make sure that you use some common sense when we're working these problems, because all these problems are in context. All right. Try and work this one out. This is the last one. So make sure you can make this one work for yourself and come back and check the work. Alright, a ramp is 17.5 feet in length, rises to a loading platform that is 3.5 feet off the ground. Find the angle of the ramp makes with the ground. So here is my triangle, and the ramp is 17.5 feet long, and the height of the platform is 3.5 feet. We're trying to find the angle to the ground, which is this angle in here. We have sine of the angle that we're trying to find is opposite over hypotenuse. So we have this going on. Okay, and then like the last problem, we take the arc sine of both sides, which looks like this. I'll cancel that. Do the same thing to this side, and do that on your calculator. And it should come out to about 12 degrees rounded. Okay, so I hope you were able to do those. You may want to go back, and if you want a little more practice, go back and start over and redo the problems without looking at the answers. Okay, that's it.